Moving ahead to our next panel, unmanned aircraft systems are everywhere in aviation press, with many proposed applications from delivery of medicines to infrastructure inspections to shuttling passengers to and from airports. At some level, we all enjoy seeing innovation take flight, but there are a lot of questions about how UAS will impact and integrate into our very busy airspace. I'd like to invite Captain Vas Patterson, the ASO Unmanned Aircraft Systems Director, and his panelists to the stage.
Are they going to get screwed up then? I think we're in the wrong.
All right. Good afternoon, everyone. Welcome to our panel. First, I'd like to thank our leadership very much for all that they've done here today. It's been actually wonderful to hear all the wonderful stories and learn all the new things about medicine and all that has occurred. So my name is Captain Vas Patterson. When I'm not doing ALPA work, I'm a United pilot 737 based out of Las Vegas, and I'm also a line check air pilot. Other than that, I work for the ASO under the leadership of Captain Jengalis and do the UAS stuff for ALPA. All right. So as many of you know, the amount of aircraft in our skies are increasing on a daily basis. Unmanned aircraft system, UAS, are starting to become more commonplace. In places like Dallas, Texas, UAS activity is on the rise with a keen eye watching from the FAA. Companies like Amazon, Zipline, Wings, and others are proving their technology for last mile package delivery for beyond visual line of sight, Rule 108 when it comes out. Companies like Amazon and Zipline have openly said they have flown hundreds of thousands of hours worldwide, and they're proving their technology. On the other side of the spectrum, we have the development of eVTOLs, electric vertical takeoff vehicles, that will be carrying passengers from city centers to Class Bravo airports like Newark, Dallas, Houston, Atlanta, and all the airports that we currently work in. Many of you have probably heard the name Joby or Archer. Those companies have been heavily invested into or partnered with by our airlines, are represented in this room. And those aircraft will be certified under the powered lift category of aircraft, and they will also be carrying people from city centers to airports under what's called urban air mobility. Urban air mobility is a part of a broader construct known as advanced air mobility. Advanced air mobility is a rapidly emerging technology or emerging sector of the aerospace industry that aims to integrate efficient and safely highly automated aircraft in the NAS. AAM is not just a single construct, but what it is rather a collection of technologies being applied to the air transportation system. You have urban air mobility, which I mentioned. You also have regional air mobility, RAM, public service, large cargo delivery, and private and recreational vehicles. What most of you may have heard is automated technology. There are also companies out there proving that technology. They're proving AI, and they're attaching it to stuff like Cessna Caravans. And all those stuff will actually eventually play a part in what we started off with this week, which is RCO and single pilot operations. The good news is, according to researchers at MIT, they just released a paper, aviation is in the safest time that it's ever been. It's 1 per 13.7 million passengers boarding in 2018 to 2022 versus 1 in 7.9 million passengers boarding in 2008 to 2017. So our industry has grown exponentially safe over the years, or it's getting safer, as Captain Ambrosi spoke about 9.9999. That's where we are. So the reason for this panel is to talk to the folks who are involved in the process and ask them and see how we could continue to maintain that level of safety with so many new technologies, novel emerging technologies in the NAS. So I'll go ahead and introduce my panel, give them a few minutes to talk, and then we'll get right into it. To my left is Captain Kirk Vining from Boeing, Savanjay Sharma from NASA, Jimmy Smith from NATCA, and Pamela Gomez from the FAA. Kirk, please introduce yourself.
Yeah, thank you, Boss. So I'm the Director of Research Flight Operations at Boeing. In the past, we're looking at new materials and new aerodynamics, but more and more, we're testing software that's augmented with learning models, or AI, if you will. And also the sustainability is high on the list. I'm also involved in features that are more towards the, we'll say operational efficiency versus just the better aerodynamics. So all of those places are good places to start with autonomy and advanced algorithms. But to this point, we're being very careful about introducing those into any operation, especially when it comes to the control of the vehicle. So we have a suite of aircraft eco-demonstrators every year where we can try things out. We also have a Cessna Caravan that's loaded in the back with basically a network server and computer scientists, and they have sensors, and they can try out object detection and things in flight and on the ground for taxi. And of course, looking forward to a few years coming up, the X-66 Sustainable Flight Demonstrator partnership with NASA will be involved in that as well. Thanks.
Shivangi?
Thanks. Hey everyone, my name is Shivanjali Sharma. I am currently serving as the Air Traffic Management Exploration Project Manager. I've been at NASA for over 14 years, and over my career I've had the opportunity to work on a number of different research projects, including development of FMS systems, new procedures, looking at the implications of putting research prototypes in different air traffic control facilities like TRACON centers and towers. And one of the things that I have observed personally through my experience is that in order for technology to really be successful, understanding the operational implications of that technology and how it will function in a realistic operational environment is essential for that success to be true. And that's why I think it's really important that I have the opportunity to engage with you all here today. And my portfolio contains a number of research projects. At its core, what we're focused on is understanding what are the capabilities, tools, technologies, and procedures needed to evolve our national airspace system to ensure that we have sustainable operations, as well as what are the implications of these emerging new entrants, and how do we ensure that as these entrants start to integrate into our NAS, we take count of the technical barriers, start to collect data and really assess what those technical barriers are, and understand what it means to really interoperate. So what does it really mean when you have a large UAS flying in shared airspace with our conventional operations? What are the challenges for ATC? What are the challenges for the flight deck? And what really needs to exist for us to ensure that we maintain the levels of safety that we have today? So that's why I'm interested to engage with you all, and I appreciate being here.
Thank you. Jimmy?
I don't want to follow that because I don't do that much.
Don't worry, man, you got it.
Jimmy Smith, I'm the National UAS rep for NACA, the Controllers Union. I've worked at a SoCal TRACON before coming into this role, and before that I was in the Air Force and DOD. Actually, in the Air Force, I started out at Columbus, Mississippi, so if any of you pilots started there, I was an 18-year-old kid trying to teach talk to a 22-year-old kid trying to learn how to fly a jet. That was really fun. So I've been doing this role now for about 4 years. I've worked with most people that are up on this panel actually on trying to do the integration piece for UAS, and that'll go anywhere from requirement, strategy, training that we need, safety, you name it. It pretty much runs the gambit from the small UAS all the way up to the MQ-9s that the military's out there flying. So nice to see everybody.
All right. Pamela?
Hi, afternoon. I'm Pamela Gomez, and I am the Director of Safety and Integration for the FAA's UAS office. I've been in that position only less than a year. Last year I spent in Senator Duckworth's office working on reauthorization as the FAA fellow, and met some of you there working on reauthorization certainly. And before that, really an air traffic background. I'm an engineer by academia, and spent a significant part of my career in the Next Gen office, working with the Next Gen Advisory Committee and trying to work with stakeholders, including all of you, to really integrate the transformational programs for Next Gen into the NAS. So I'm not new to integrating new technologies, whether we're buying it or industry's buying it, trying to figure out all of the safety characteristics and the safety assurance for integrating those systems into the NAS. So I'm a stand-in here for my boss, Jeffrey Vincent, today, and he's sorry he couldn't be with you.
All right, thank you all so much. So, as pilots, we assess and manage risk on a daily basis. That's what we do. As you've heard throughout this week, people talk about having 2 people on board and so forth to manage risk. But new entrants is a new risk that we're not used to seeing. So I have prepared questions here that I'm just going to read, and then we'll get into it. The risk associated with the rapidly advancing technologies in aviation, particularly unmanned aircraft technologies, are unknown. How fast they should be implemented, oversight, monitoring, are all things we need to consider when these technologies start to become more frequent in our airspace. What we do know, which I mentioned earlier, is that we're in the safest time for aviation right now from a commercial standpoint. So, can each of you take a minute and give us a little detail about your biggest concern with the projected unmanned aircraft technology models that we have today and how they will be implemented? Also, how could those affect the standards we have put in place for aviation safety? Kurt, let's start with you.
I'll take the rest of 30 minutes on that one. Let me just give a little story. My first encounter, I suppose, with a large unmanned aircraft, a 70-foot wingspan global observer in 2011. I was at Edwards Air Force Base for Boeing testing the 747-8. And we're doing runway takeoff testing. So you need perfect air conditions. You get up early in the morning, the sun just comes up, and there's barely a breeze. And you're getting ready to line up on the runway, and we're looking for a takeoff clearance. And said, no, you got to wait for this hydrogen-powered global observer to fly by. I'm like, where is this thing? And I look up, and here's this monster. Just looks like it's only doing 20 knots, just slowly. I'm like, come on, I need to get this done. I've got 20 conditions, and the weather's just right. And it's just ambling along. So finally got out of the way, and we were able to go. And now, so the next day, if any of you worked on Global Observer or family, no discredit to you, whatever, but in my heart after that, I was thinking, man, I just hope that thing just gets out of the way. And well, the next morning we get in there, and I'm lined up, ready to go, and the tower says, no, you can't go. I'm like, oh, it's that Global Observer again. He said, no, it crashed. And he said, and I said, well, good, so we can go, right? He said, no, we don't know where it crashed. So I don't know if it's because it's hydrogen and just like there are no parts left. I
Just disintegrated.
Yeah, they couldn't find it, so we're delayed. So I tell that story because it highlights a lot of things. First of all, the mixing of 747 and drone operations, separating airspace, and how can we really segregate the precious airspace, runway occupancy time, and for that type of operation? How do you trade that? Secondly, just the different needs of the different vehicles. The Global Observer has a whole crew of ground operations, and they got to talk to the tower operations, and they got to coordinate with me. So all of those are really high risk areas. I say risk in terms of systemic risk.
Right.
One more element that I'd like to bring out, and I don't want to take more time on this, is just the human element. So you think of drones, you think of autonomy, you think of AI, and you think, okay, so it replaces the people. And more importantly, I think there are still people in the system, and you got to account for that. And often I find that's not being thought about. So that's another risk.
Okay.
So if you have right now you've got a PIC that's responsible for the airworthiness of the airplane. Yes, the mechanic, they return it to service, but then it's the PIC who's responsible. That's why we do a walk around, or at least you send your co-pilot out to do a pre-flight walk around.
There you go.
Right?
That's the correct way to put it.
Right, yeah. So now you're an operator in Cincinnati and you're getting ready to start up a drone that's in Sacramento. Who's going to do that walk around? Do you just delegate it to someone? Do you delegate it to a mechanic? Well, are you going to pay them more and train them more? And so all of those distribution of that PIC function needs to go somewhere, and I think that's a concern that's not necessarily adequately addressed. And cabin crew as well. So you're going to have people occupying these vehicles, passengers that are either actively compliant, passively compliant, passively non-compliant, actively non-compliant. Who's going to tell them to put the seatbelt sign on? So that's areas that I think about keep me up at night.
Awesome.
Yep.
Thank you, Kurt. Shivanjali, please.
Yeah, so I think I have two areas that I'd like to highlight that are concerns, but before I do that, I did want to make sure I highlight that NASA, as in terms of its role, is not a regulator. Our function really is to conduct cutting-edge aviation research to ensure that the U.S. maintains its superiority in terms of aviation safety as well as technology. So that's kind of the view and the perspective that I have. But there are a number of risks, and if I focus on advanced air mobility, which is different than large transport carrying operations, I think there are still a whole host of technical barriers, and I'll just focus on one, which is probably one of the bigger concerns, which is communications. So not even thinking about spectrum and spectrum allocation, but what occurs in conditions of lost link if you no longer have command and control of that vehicle. That's just one instance of a communications contingency or challenge. What occurs if the remote pilot that may be, an operator on the ground somewhere loses the ability to communicate to air traffic? And then what happens when there's communication challenges between the remote pilot and the other flights that may be operating in that area? So just communications in terms of the technologies that are needed to enable safe operations. A lot of that does not quite exist yet. So I think there's a whole host of technical barriers that we need to acknowledge and address. So that's one concern of mine from the technical perspective. And alongside that is maybe a slightly different perspective, which is the hype that's associated with this emerging sphere of aviation operations. I mean, I think 10 years ago, it was predicted we were supposed to have self-driving cars, right, populating our roads. And so I think we are very early on what they call the Gartner hype cycle, which is, you can look it up, it's a curve that shows where technology really is in terms of its wide adoption and use. And I think we're still very, very early on the hype cycle for advanced air mobility because there are so many challenges that remain and technical barriers that need to be addressed, whether it comes down to detect and avoid situations, what are the capabilities that are required on the flight deck. I mentioned communications. Captain Kirk, which I just love saying, to be honest, mentioned the functional allocation and roles and responsibilities, not to mention some of the regulatory challenges. So it's just I think for me as a nerd, I love it because there's so many problems and good research topics here, but I think it's important to address, before we can assume that there'll be hundreds of these operations flying tomorrow, it's important for us to really think about the real technical barriers that exist.
Awesome. Jimmy, what's your thoughts on that?
Sorry, I wasn't paying attention. I was on landline. I think one of the challenges I've seen as I've come into this, and when I first started, it was, hey, as we integrate these drones and whatnot, we can't affect ATC. We're not allowed to do that. And the more that I got into it and started to learn, I would go, well, how can you even make that comment? How do you expect to put this many pieces of metal into the NAS? I don't care if it's Class G or not. Eventually you're going to grow out of the Class G and get in controlled airspace. You are going to have an impact on air traffic. You're going to have an impact on other users in the NAS. What you really need to say is how do we limit the negative impact? How do we keep the safety there, number one? And also, how do we keep the efficiency that we have? So I think we're starting to feel a little bit of those growing pains. No offense to the agency as they were going forward, but as it's growing, I think we did a lot of the work previously thinking, we were scope locked onto just the drone and not seeing what is the potential impact outside of that. And we're now starting to see that. The agency's working on different regulations to try and increase access to airspace. The BB loss is going to be a huge thing whenever that comes down the pipe. But that's got a lot of impact on everybody in this room, right? When you're flying your plane, you see that drone out there, you want to know, hey, is everybody on the same page? And part of that is there traffic on that page? Because a lot of times when you're flying in, hey, what is that other person doing? You're almost relying on us. If I don't paint that picture for you, or I don't seem too confident on that radio, what's the first thing you're going to do? Okay, what's going on here? And you're going to be a little, head on a swivel, which you always do, but you're going to be probably a little more nervous at that point. So I think that's kind of a challenge moving forward, is how do we make sure that everybody's operating on that same page? And that's why I don't like hey, we can have zero impact on X. We all work this together. We all impact each other. So I'd say that's probably my number one thing, right?
Thank you, I appreciate it. Pamela, please.
Thank you. Interesting, because I think I've kind of pulling this thread of all the things that you just mentioned. As an engineer and working in air traffic for most of my career, I really come at it from an airspace perspective, an air traffic perspective, and pulling in all of the technology and the operations and the procedures that have to go along with it. And those things take time. So appreciate, that we are very much early on. I didn't know the curve, the title of the curve. I should know that.
Just know it existed.
But the bell curve in terms of acceptance, I think, and building like a decade of really building out the technology and a decade of really figuring out like how that technology kind of starts to permeate into the NAS, and then really a decade of implementation. So I think the hype is actually something that, for those of us who worked in integrating things into the national airspace, these things take time, and rightly so, for sure. I think from a regulation standpoint, because I'm now sitting in aviation safety, which is interesting. So as the regulator and trying to establish the rules that govern these systems is really trying to take that crawl, walk, run approach, and that's just not a gimmick or a phrase. That is actually what we're doing. The crawl phase is figuring out, like, through waivers and exemptions in rural areas and in low altitude airspace, primarily in Class G, how are we operating these things? What data can we collect, and how? What are the operating parameters and the characteristics of these drones primarily today? Certainly operating the NAS. So I think for me, the biggest challenge is the variability in these aircraft, in these vehicles. There's so many different performance characteristics in these operations. We have drones that look like a weather balloon, that operate like a weather balloon, that go straight up and straight back down, operating from drone in a box. You know exactly where they're going to be. We can plan for that. We have cargo drones that are going from point A to point B. It looks like a regular aircraft. It doesn't have any people on it, but we can plan for that because we know those characteristics. There's a lot of new technologies that are really looking at end of the envelope kind of research areas for drones to operate and really take some of the risk out of those operations as well. So you might be transferring the risk from a ground risk to an air risk, and how are those going to be incorporated into the NAS? So I think the variability in these drones, certainly from the perspective of the UAS office right now, is one of the biggest challenges.
Okay, thank you for that. I'm going to pull on a few of those strings a little bit. Jimmy, like the pilot group, like the flight attendant group, there's a lot of newness in our ranks, right? How do you manage that newness with the novel entrances into the NAS?
So, yeah, well, we had a perfect storm, right? Everybody in the industry had a perfect storm about, 4 years ago, right? And then they shut down our training pipeline, for a good couple of years, and then retirements and all that stuff. So to say that we're new, we are very new and also very short-staffed right now. So just trying to keep up with the recurrent training that you currently have and trying to teach, new controllers, all the stuff that we currently do, and then lumping on top of this. I think, I don't want to, we're always going to put safety number one, right? We're only going to take on what we can take on, right? But as the staffing and the people are getting overworked, and then you have the overtime out there, and then you're trying to put on this new stuff, I mean, it's definitely going to start to, I mean, it's going to stress. You're going to start seeing cracks, without a doubt. But the agency and NACA, we work very well together on, hey, where are we lacking? Where are the deficiencies in our training? Before we implement, whether it be a new piece of equipment or a new procedure or these new entrants as they come in,
Right.
we are going to sit down and we are going to look at it very in depth. And trust me, I am not shy, if that hasn't come across today, to put our concerns out there. And I take into the concerns of what I think the aviation industry as a whole, everybody that's using this NAS, that to me, you said it before, it's a resource, right? It's a national resource to protect this stuff. And I think it's also not only good for this group here to be protected on their safety, but let's be real, the industry, whether they know it or not, the unmanned industry, they probably, because if something bad were to happen right at the get-go, what happens?
Yeah.
They'll falter. And so many people will start losing money because they'll lose the trust of the public. We are there to protect that. Okay. So to make a long answer into a short question, but that's basically what we do then.
Okay. I'll make it longer.
Go ahead.
So
Go ahead.
So the folks that I work with that are developing some of these ideas, they're new too. They're the younger creative minds from the computer industry. So like on our Cessna Caravan, I'll be the old grungy guy up front, the flight test hardcore, and I've got computer scientists in the back, and they'll say, oh wait, I need to bounce the node. And I'm like, does that mean knock it off? Does that? There's some phraseology I'm used to hearing here. So, but they bring the dynamic, the new vision, the ideas, but they're bringing it into a space that's completely new to them. Like we've had creative ideas that would say, hey, you can have one person controlling many airplanes. And I'm like, no, wait, that just doesn't work. And they're like, well, but a controller does that. I'm like, no, you don't understand. Jimmy gets to control that conversation.
Yeah.
Like he'll say something and we take turns responding. And you can't have Jimmy issuing a clearance, Boeing 123 climbed to 270, and Boeing says, now wait a second, I'm on the other line. I'm getting a ground taxi clearance in New York. Just wait a second. Yeah. So, the creative, they're new. It brings fresh energy into it, and we need that. But it needs to have some reason to it, and we're the ones that need to bring that.
I think that's a really good question too.
Yeah.
Guys, from someone sitting, doing reauthorization, you can really see the newness everywhere.
Yeah.
Certainly, the new pilots, certainly the controller shortages, certainly all of the folks in the aviation system and the new technology. So this kind of intersection of all these things is real, and it's a real challenge. I think. Kirk, you bring up a really, really good point because, you think about the next version of all these tools that are going to help all of these individuals really manage that risk and the capability of these new technologies. I don't know if you have any kids, but if your kid can do something like 3 seconds that takes you 10 seconds, so,
More
you
like
can
10 minutes.
Right. So you can see how those things happen, but, to, bring that to something real, for me, it's thinking about like that next version of TCAS, right? Like ACAS XU, and how the technology is going to provide the detect and avoid real time, and then the additional communications that can layer on top of that really can act like your cell phone and, provide vehicle to vehicle links and give that real time tactical kind of deconfliction capabilities. That's a long way away, but those technologies are being explored, the research is there, the capability is there. So how that all kind of comes together is something that we need to be working towards to get together collectively.
I agree. For you, Pam, do you see any regulatory hurdles that would prevent efficiency and safety, and how that would affect safety? Like, from your seat, what do you see from a regulatory standpoint that would be a hurdle?
Yeah, I mean, I think that, certainly we've been maybe, criticized a little bit for our slow to regulate. I think we have gotten through some of that with BV loss exemption, certainly. We had the Beyond Visual Line of Sight Aviation Rulemaking Committee a few years ago. That has really yielded some good consensus recommendations to the agency. And we're utilizing that to build our BV loss rule. So that rule has left the building, and we anticipate hopefully that NPRM will be out here at the end of the year or the beginning of the calendar year. And that is for beyond visual line of sight operations in Class G below 400 feet. So a regulation versus waivers and exemptions. So just taking that kind of next step beyond the crawl stage,
Yes.
maybe a little bit into the walk stage, but in these specific areas. And I think that's really helping. And we're still on the regulatory side using waivers and exemptions for things that are in much higher, maybe a higher risk, not much, but higher risk areas. Certainly in airspace that, may be more dense operations. And we really need to figure out what those specific solutions are for those specific constraints and limitations that we're using and manage the risk on an individual basis and going through our safety assurance processes. So I think the regulatory hurdles, it does take time, but we have, I think, found a sweet spot in terms of allowing this economy to thrive and to flourish, but also figuring out ways to do that in a really smart, slow, safe way.
Awesome. Thank you all. I'm going to move on to the next question because that was question 1 and it's like 10 minutes left. So this is really a great conversation. So there's a lot of new technology around. How do you guys see that actually shaping future technology or future aircraft and in the unmanned space and in the manned space for that matter? How do you guys see that actually shaping up?
I'll start with that one. There's a general idea, and most of you in the audience probably have heard me talk about this roadmap where you have a generation of airplanes getting more and more automated. And therefore, if they're more automated, then they're easier to fly. And if they're easier to fly, then the workload is less. If the workload is less, you can remove a pilot just during cruise. And if you can remove a pilot during cruise, then you can just remove a pilot for the flight. They have this continuum, and that's flawed. It is inherently flawed. And I'm not just pandering to an interested, well, I want to give you the specific reason. So we designed that second control station not only so your co-pilot can run your checklist and talk on the radio and learn how you do it, but there are significant design reasons, design assumptions to have a second control station. For example, a control jam. Even if it's an Airbus, that you lose the stick, don't worry. There's another stick over there. Or a windshield. I was climbing out of 20,000 feet in a Learjet, and the windshield just shattered, the outer ply. It's like a baseball bat, boom! And so I'm ducking under the glare shield, but don't worry about it. I was worried about it then, but don't worry. The other pilot could do that landing. They can see out of there. The seat track, we've had seat track issues. If that seat jams, don't worry about it. You got the other. So there's just design issues. There's a whole lot more design issues why you need that second control station and a person occupying that second control station. Let's not even go on to the failures that require immediate action, like autopilot hardovers and such, where you have to have a person at the control ready to respond. As we're finishing up the 777-9 flight test certification, and the 737-10 is coming along as well. But a big part of that is the functional hazard assessments, and we take each possible failure, and you have to assess what will it look like to the crew, how will the crew respond, what's the level of severity of that. And I'm telling you, there were just this last quarter, 1,600 that we're going through, and we did 6,000 last year. There's just so much work. And whenever we do that with the pilot in the room and the engineers, and they all agree, check it off on to the next one, we assume, whether it's tacit or explicit, that there's 2 crew member in there. And so you would have to go back and redo all of that with a different assumption. So,
Okay.
Yeah.
Joanne?
Well, I'll just add that I think it's important to distinguish between transport category, rules, regulations, and challenges with increasing levels of automation, and then advanced air mobility, which is, potentially operating under a different set and also maybe operating under a different safety continuum. I believe that's the term that folks in AVS have been referencing, which resonates with me. So I think there's two different conversations to have here. And just looking at the time, all I will say is that I think it's important for us to assess certain technologies and capabilities that may be applicable, for example, for advanced air mobility and remotely supervised use case, because that capability or technology could have implications, for example, for GA aircraft and helping address issues like CFIT. So I think there's opportunities that technology advancement can bring to other realms of aviation, but the advancements, I think, are required and needed to even enable some of these use cases. I mentioned the challenges in the past, but I think there's also applicability to the other realms of aviation. But just looking at the time, I'll leave it there.
All right, thank you so much. All right, that is it. Thank you guys for joining us. We do appreciate you listening. And if you have questions, some of these folks will be around. Please engage nicely and talk to them.
Yeah. Thank you.